Good morning, afternoon, or night, whenever you want to watch this. Hopefully you can see the board better. I switched from dark to light. When we solve inequalities, it's very similar to when we would solve equations, okay? Let me actually just move this over. Let's move that over this way. Let's move this over this way. That way you see a little bit better. Just like when we solve equations, we solve it out the same way, but instead of x being one number to make it true, x can be a whole bunch of numbers, right? So I'm gonna start solving this like normal. Like normal, what I'm gonna do is I'm gonna subtract 9, subtract 9. Those guys cancel. I get 3x is less than or equal to 15. And then I'm gonna divide by 3. Steps stay the same. But I get x is less than or equal to 5. Now, what this tells us is that x can be any number that is either equal to 5 or less than 5. So how we write that on the graph is in the middle, I like to put the 5, and I like to start here, right? 4 is smaller, 6 is bigger, and this goes on and on and on till negative infinity, and this goes on and on and on and on till positive infinity. You don't really have to write all the numbers there, but I like to just give me some type of idea. Now, x can be equal to 5, so I'm going to fill in the bubble, okay? And x is less than. Well, which way's less? Is 6 less than 5 or is 4 less than 5? I think it's 4, so I'm going to come this way and go like this. So any number for x that is less than 5 is going to work, or 5 or less, right? So like in my original equation, let me see if I can move this. Let's move this guy over this way. Let's move the page. Let's move the page over this way. Let's move this guy over this way. Let's move this here. Let's actually shrink this board. Let's shrink this board a little bit. Let's make this bigger. How beautiful, right? Kind of, right? Now, what I'm going to do is I'm going to rewrite my black equation, but instead of x, I'm going to put a parenthesis. Because I'm going to plug in some numbers and see which numbers work and which numbers don't. So if I plug in, let's say I plug in 3. Is 3 less than 5? I think so, so it should work. If I plug in 3, let's equate this. What's 3 times 3? 9. And then I'm going to drop down the rest of my equation. What's 9 plus 9? 18. Is 18 less than 24? Yes, check, it works. So -3, if I -3, it would work. What if I plugged in, what if I did the same thing, but I plugged in 0? 3 parentheses 0 plus 9 is less than 24. 3 times 0 is 0, so 0 plus 9 is less than 24. And again, that checks out, it works. So as long as it's less than 5. Now, what if I try a number bigger than 5? What if I try a number bigger? Why don't I try 7? I'm going to try 7. 3 parentheses 7 plus 9 is less than or equal to 24. 3 times 7 is 21. 21 plus 9 is less than 24. Is 30 less than 24? I hope most of y'all would say, or all of y'all would say, no, it does not work, right? These two worked, and that one didn't, right? So if it works out in this equation, it works out here. And now I can just plug it in the same way. I'm going to say, hey, 3 is less than 5. It works. Who would have guessed? 0 is less than 5. Boom, it works. Who would have guessed? But in this one, I plugged in 7. Is 7 less than or equal to 5? No. So as sloppy as that looks, all I did was I said, hey, this is my equation. If I plug in a number less than x, it's going to make the statement true. If I plug in a number bigger than what it's supposed to be, it won't make it true, right? So why don't we try it with a more complicated question? Let's see if I can erase everything. Oh, I did. Now let's do the same idea. I'm going to do 8x plus 4 is greater than 3x plus 9. Is that going to work? It actually will. Who would have guessed? I kind of stopped saying that. I will stop saying that. So we solve this equation. Let's see if I can make it bigger, actually. Make that bigger, move this up. Make that bigger, move this up. Cool. Now, like we solved the equations before, we got to move all the x's to one side, everything else to the other side, right? Now, I like when all my x's are on my left side, so that's what I'm going to do. I'm going to subtract 3x from this side, subtract 3x from this side. Boom. So I get 5x plus 4 is greater than 9. And then subtract 4. I get 5x is greater than 5. Divide by 5. Divide by 5. It works just like equations, but your only new rule is that it's not just one number that makes this true, it's a whole bunch of numbers that make it true. Now when I want to graph it, I'm going to put 1 in the middle, 2 is bigger, 3 is bigger, 4 is bigger, 0, -1, -2. Start at 1, and x is bigger, this way. A little hint when you're solving, when you're graphing them, is if it's like this, if it's x is bigger than a number, it goes that way. If it's x is smaller than some type of number, it goes that way. Okay? And then the other hint is if it's this side or this side, it's an open circle. If it's this side or this side, it's a closed circle. And that closed circle means that it includes it, right? We include it. Like the last problem we did, we included 5, because 5 would have worked. But in this case, you can't plug in 1. And let's just show you the example for that. So if I plug back in 1 to this equation, so let me do that. I'm going to do right here. 8 parentheses plus 4 is greater than 3 parentheses plus 9. I'm going to plug 1 back in. Boom, boom. Now let's solve it. What's 8 times 1? 8 plus 4 is greater than 3 plus 9. At the end of the day, I'm going to get 12 is greater than 12. Quick question. Is 12 greater than 12? No, it's not, right? They're the same number. Since 12 is not greater than 12, we do not include it. Now, if we would plug the number in bigger than 1, it would have worked. If I plugged in 2, it would have worked, right? Blah, blah, blah. That's how you solve that, right? I'm going to try and make this video 3 more minutes longer. So let's erase this, and let's try it one more time. Now I'm going to make this one a little more difficult. Let's do 3 parentheses 8 minus x parentheses is less than or equal to. Let's do 10x plus 5 parentheses, just like that. All right, this should work. So let's plug some stuff in. Well, not plug some stuff in, but let's start putting things together. Well, I have a left side and a right side. I got to simplify them both. So let's simplify this side. Boom, here I get 24 minus 3x is less than or equal to. And on the other side, I got to do the same thing. I got to distribute. This 10x, we can't use them yet. Boy, I messed up this problem. Hopefully it still works. Hopefully it still works. I'm going to have to change this one on the end. I'm so sorry. When I did it in my head, I goofed it up. Make that a 2. This should work. Oh, let's make that a 4. I don't know. I'll figure it out. Let's make that a 6. Final answer. Actually, that should work. Boom. I'm so excited. Yeah, this video is going to be a little longer than 10 minutes. That's okay. But now we got this side and this side. If we look at this left side, we have a constant and a variable. Those guys can't go together. We're set. But we can clean up the other side. The x's can go together, and the constants can go together. So if I put the x's together, I get negative 10x. If I put the constants together, I get negative 46. Now, we do that because if we get we have a positive and a negative, you do the opposite. We do opposites, means we subtract, keep the bigger sign. Same sign, put them together, keep the same sign. But now we can move things side to side. Add 10x to this side. Add 10x to this side. Remember, you're adding the x with the x. So we get 24 plus 7x is less than or equal to negative 46. And then we subtract 24, subtract 24. So we get 7x is less than or equal to negative 70. And we divide by negative 7. Divide by 7. I'll see if I can shrink this board because I've kind of made it huge, huh? That guy's coming with him, is he? That's okay. We'll manage it. And then our final answer is going to be x is less than or equal to negative 2. Okay? Now, when I plug that back in, I'm going to get a real big number. But graph-wise, I got here. This is at negative 10. And x is less than or equal to. So we include it. I'm going to have more examples for you guys later. But let's just keep this moving because we have 11 minutes. Last problem I'm going to do is same idea, but with a fraction in there, okay? Just because we got to be familiar with fractions a little bit. So let's do 2/3 x plus 5. Actually, I lied. The last problem I'm going to do is when we divide by negative. If I have negative 4x plus 12 is less than or equal to 20. It's going to work the same way. We still do the first step the same. We still subtract 12. Okay? But there's a new rule when it comes to inequalities when we divide by a negative. So right here we know we got to divide by negative 4, right? Divide by negative 4, divide by negative 4. When we divide by negative, everything else you run the same. This sign is going to flip to make it true. The sign needs to flip to make it true. So when we do that, we get x is greater than negative 2. So I'm going to start here and negative 2. I'm going to color it in. And I'm going to plug it in this greater. And let's try those 3 cases. Let's try the 3 cases that make this true or false, okay? So let's try those 3 cases. So I'm going to try when x is bigger than negative 2, when x is smaller than negative 2, and when x is equal to negative 2. So let's try a number like negative 3, and we'll try a number of negative 1, okay? We're going to try those 3 terms. Can you see the negative 1 on my board? Yes, you can. Good. So let's try a number that's smaller. Let's put negative 3 up here. When I plug in negative 3, what is negative 4 minus times negative 3? That gets you positive 12. Add the 12 from before. Boom. And then at the end of the day, I'm going to get 24 is less than or equal to 20. If we did not flip that sign, it wouldn't be true. We know the blue is not going to be true. We know. Check. It does not work. Now I'm going to try is equal to. I'm going to try the 2 this time. So I'm going to write the same equation. Negative 4, parentheses, leave here. Because plugging it in and checking your answers does not kill you. It does not kill you to check your answer. Plug in a negative 2. We'll get 8 plus 12 is less than or equal to 20. Is 20 less than or equal to 20? Because it says or equal to, it works, right? Because it's 20 equal to 20? It might not be less than, but it is equal to, right? Let's see if I can shrink this. Nope, that doesn't work. Shrink this, shrink the whole board. I can't shrink it anymore. So we got to be a little more sloppy this time, huh? And lastly, let's try the same equation, but let's plug in negative 1. Negative 4, parentheses, plus 12 is less than or equal to 20. Plug in negative 1. Now we have negative 4 times negative 1, which gets you 4 plus 12 is less than or equal to 20. Is 16 less than or equal to 20? Boom, it works. So because we divided by negative, flipping the sign is going to make them true. I'm going to end this video pretty quickly, and I really appreciate you guys for popping in. Thank you.